This video tutorial is for quantitative mass spectrometry imaging. Most quantitative MSI experiments rely on standards of known concentrations. The use of internal standards could help correct for the region-specific matrix effects, and allow analyte signal to be converted into absolute surface concentrations upon generation of an appropriate calibration curve. If you are starting directly from this section, you will need to upload the RDS file in the Upload MSI Data module. Alternatively, if you have already uploaded the data, you can proceed directly to the quantification module to quantify the metabolites of interest. For more information regarding how to upload RDS file, please watch the de-isotoping tutorial video. First, I navigate to View MSI Image module, and plot the spatial distribution of the internal standard, olanzapine. The MZ value of olanzapine is 313.1471. By clicking the plot button, the ion image of olanzapine is generated. You can see that olanzapine at 5 different concentration levels are detected, and there are also 4 samples next to the olanzapine internal standard spots. The generated ion image is automatically transferred to the image analysis module, and from there, we can perform quantification analysis. Next, we can draw regions of interest to select the olanzapine spots. For a detailed tutorial on how to define regions of interest, I recommend watching the statistical analysis tutorial video. This video provides step-by-step instructions and explanations on how to accurately define the regions of interest. After drawing the regions of interest, you can click the display button to view the defined regions of interest. If you are not satisfied with the defined regions of interest, you can click the Undo or Reset button to redefine them. Once you are satisfied with the defined regions of interest, you can proceed to the quantification module to build a calibration curve, using the defined regions of interest. First, enter the MZ value of olanzapine, and click Show Intensity Concentration Table to calculate the mean intensity for each defined region of interest. Next, you will need to enter the corresponding concentration for each olanzapine spot. Then, you can click the plot button to generate the calibration curve. If you attempt to directly click the plot button, a message will pop up, reminding you to select at least 2 rows to generate the calibration curve. The reason not to automatically generate the calibration curve using all concentration levels is that they may not always fall within the linear dynamic range. Therefore, users have the flexibility to choose which concentration levels to include, allowing for more accurate calibration. You can try with different concentration levels, and select the most appropriate ones to build the calibration curve. For now, let's proceed with using all of the available concentration levels to build the calibration curve. Now, you can enter the intensity values in the text box below to convert them into concentrations. Let's try to quantify the 4 samples next to the olanzapine standard spots. To begin, click the Reset button to eliminate the previously defined regions of interest. Afterwards, draw the regions of interest over each tissue sample using the way as we did for the olanzapine standard spots. Once you have finished defining the regions of interest for the 4 tissue samples, click the Display button to view the defined regions of interest. If you are satisfied with the defined regions of interest, proceed by clicking the Compare Regions of Interest button to calculate the mean intensity of each sample. Next, you can copy the mean intensity values for the mass feature 313.1471, which corresponds to olanzapine. Then, paste the intensity values in the text box provided in the quantification module. Please remember to separate multiple intensity values with commas. Once you have pasted the intensity values, click the Quantify button to obtain the quantification table. If you click the Quantify button again, the quantified results will be displayed in the calibration curve as well. This interactive feature allows you to easily view and analyze the results. It is important to note that if the entered intensity values fall outside the linear calibration range, the resulting values will be displayed in red color in the calibration curve. This is used to draw attention that the calibration result for these intensity values may not be accurate. Finally, you have the flexibility to adjust the calibration curve by adding or dropping certain concentration levels, and then reperforming the quantification. This allows you to refine and improve the accuracy of the results based on your specific requirements and observations.